Good morning, everyone. This is great. Thank you for joining. I know it was late last night. Many of you probably saw Zed. How cool is Zed? You guys like him? Yeah, of course. I know you're already packed and ready to head home, but thank you for joining us in this session. So welcome to the session on Globe Life's ability to accelerate innovation with self-service analytics. So we'll be learning about Globe Life, how they went from running one model at a time and querying more than 10 billion records and about 200 models simultaneously in less than 30 seconds. So you're all thinking, sitting here, why should I care about it, right? We wanted to share Globe Life's experience with the self-service analytics so that other financial and insurance companies can learn from that journey. So Globe Life shares an analytic, so how it's, with Dilip and Arthur will share its analytics environment, how they're maintaining security guardrails to empower the actuarial and business teams to meet time-sensitive regulatory requirements and quickly perform deep analysis for business automation. So this topic is more relevant than ever because of the growth of our data and then the lack of ability to democratize all of that data for many personas. My name is Srikanth Sopirala. I am a Principal Analytics Specialist Solutions Architect, and I'm joined by Arthur Heason, Director of Data Strategy and Services, and Senior Manager for Cloud Engineering and Cloud Platforms, Dilip Kumar. So as part of the agenda in today's session, what I will touch is I will introduce self-service analytics, how we see at AWS, and then I will bring in Arthur to talk about their mission, their challenges, their objectives, and how they overcame these challenges with moving to AWS Cloud and analytics for insights. So Dilip can then dive deep into the architecture that they've used to kind of build for self-service analytics platform and the framework to enable the actuarial users and to build their models. So let's talk about self-service analytics in general. So before we do that, before we jump into the session, let's see what self-service analytics is. So is self-service analytics, is it like a vending machine, where your analytics are vended to you by clicking a button? Because let me tell you, every time I go to my office, I try to vend something, I get something else. So that's what happens to me all the time. Or is it get IT out of my way? Just give me a database so I can just go do my analytics on my own. Or is it let me run my reports and then don't ever bother me again, right? Just give me a tool so I can run my reports and I can do my own data on my computer. So that's another approach. Or is it empowering the business users to focus on analytical tasks on their own and with activities such as exploration, verification, and visualization? If you guessed D, you are absolutely right. Right? Because self-service analytics is about accelerating innovation and reducing IT dependence and upskilling the business users so to achieve the desired business outcomes and with the right insights. So when you look at organizations, there are a variety of personas, right? For example, self-service analytics does not just apply to business analysts or business intelligence professionals. I think it also applies to a broader spectrum of personas, including data engineers, data scientists, and database developers. Because of each of these personas are trying to innovate in their own way to achieve the outcomes and the right business outcomes, right? Either indirectly or directly to help the business outcomes. But self-service analytics generally is very challenging, right? I'm sure most of you guys are familiar with it, right? We see that with many, many large customers, particularly in financial and insurance industries. It is challenging because it is very difficult to predict costs, right? Self-service analytics might mean one thing to another organization, but it may be different for somebody else. Like business intelligence, for example, right? For one company, self-service intelligence is business intelligence or report generation. It also could mean enabling ML capabilities for data scientists. So customers have multiple analytical needs when it comes to self-service. So So when it comes to tools and environments, there are a variety of tools to enable self-service, right? Based on the analytical needs of the personas, right? Well, you can have ML tools, you can have self-service SQL tools. So there are a variety of tools. For example, self-service for a data scientist may be different than a self-service for somebody, analyst focused on business intelligence. So also, there are a variety of tools and analytical services that are very difficult to manage, right? Managing all the tools that each persona uses, it is very complex. It is not easy to manage. And the most important thing specifically for financial industries is the security, right? Because with so many personas and so many services, there is always compliance risks and security risks, right? Particularly with large financial organizations like Globe Life. So when it comes to self-service analytics requirements, I mean, there are a few things, right? Customers are primarily looking at how do you democratize access to the data, to the tools, and training to make sure they enable their organizations and users to gather business insights more quickly, right? Because they also want to maintain control and while providing access to the data and tools by creating security guardrails, right? And throughout the years, we have seen customers, they have accumulated massive amount of data, so they are looking for scale and drive orders of magnitude of change. Because all that data sitting there, they want to make sure that they can give access to the right people, right personas, so they can gather insights. So what are customers looking? Customers looking for least cost platforms, best performance, which can be managed easily, like serverless frameworks, and they want to achieve measurable success quickly. So to achieve these capabilities, what customers are building is modern data architectures on AWS. What it allows them to do is it is allowing them to build scalable data lakes, right? And also provides a broad and deep collection of purpose-built data services of performance and scale for use cases like interactive dashboards, log analytics, data processing, data warehousing, and things like that. And also, it is enabling them to move data around the perimeter in this modern data architecture, right? From the purpose-built data warehouse, for example, from an RDS to a data lake, for a data lake back to an RDS, right? Also, the other key thing is setting up governance and compliance in a unified way to secure and monitor and manage access to their data. So the last thing is choosing cloud services that give them low cost without compromising performance or scale. And that is where modern data architectures on AWS really can help. But you may be all thinking, I mean, why modern data architectures, how is it even relevant to self-service analytics, right? Because it is. It allows them to simplify administration, right? Provides various analytical tools to accelerate adoption, productivity, just like Globe Life did the acceleration in terms of the actuarial users. And the most important thing it also provides is a seamless integration environment because of the platform that AWS provides to enable self-service analytics. And the key thing is this architecture provides an integration environment to enable self-service analytics. So Globe Life has used this approach and enabled their actuarial users not only increase their productivity, but achieve the right desired business outcomes. I'm delighted to introduce Arthur Heason, Director of Data Strategy and Services, to talk about Globe Life's journey into this. Arthur, thank you.
Thank you, Srikanth. So I'm very proud to be here to speak about what the team at Globe Life has done. It's been a challenging journey. We almost had too many exciting things to include, so we had to make some choices. Really, the self-service analytics journey, though, is the core of our story. And the way we look at managing the cloud platform with how we do the analytics at AWS, we always take all of the things that we know are in the queue, but then we're really watching and working with our business partners to align the business cases, and in addition to that, make sure that we're calling out potential technologies in advance. A little bit about Globe Life, though. Globe Life Insurance, if you're not familiar with us, we actually are the largest issuer of ordinary life insurance contracts in the United States. And we have the largest number of life insurance policyholders in the U.S. This will come into play with a lot of what we talk about today, because that fundamentally sets us with an extremely large volume of data to do models on the regulatory reporting required associated with all those policies. A lot of policies means a lot of data. So we'll tell the story today of how we are meeting the needs, what the challenges were, and also how we fulfill our mission as part of the IT team to make tomorrow better. The objectives that we are aimed at here is, again, large base number of policies. The modeling that happens for actuarial teams has undergone a series of transformations of new requirements, so that the models that used to be frankly very complicated to start with have become proportionally, exponentially more complicated. And so one of the dynamics is that just pure base volume of data plus complex models means a lot of compute requirements. That's our baseline. The regulatory environment has changed, making those models more complicated, requiring even more compute, producing even more data than the old style models produced. But on top of that, dynamic that we see is that when processes and the environment becomes more complicated, not through external pressures, the actual number of times we need to run a model actually goes up. Because if you have something complex, you want to understand, why is this outcome occurring? Well, one of the best ways to do that is attribution runs, scenario tests. Well, that's a further multiplier. So that's why whenever Srikanth was introducing this, we use the phrase orders of magnitude of improvement as our baseline of how we can succeed. The objective then has to be that we can achieve that for these regulatory requirements, make sure that that service then is not something that, if we make it so that there's going to be run 10 times as often, the worst case scenarios, they have to come to IT every time they want to submit a job. That isn't going to be a solution that's viable at all with our audience. We also are dealing with the challenges like a lot of companies. You have an existing base of your platform and all the services and things that you're running on premises with limited infrastructure, and certainly not achieving the scalability of the cloud. So we have to address the elasticity of the requirements, and also in this process make sure that the existing volume of data that we're dealing with, which is in the high terabyte count, for us that's a lot of data, and certainly with legacy technologies, very difficult. But if we achieve this right and achieve the orders of magnitude of improvement and deploy that to our audiences of advanced users, then success means that we can actually then focus on the next business problem and not be in the business of commodity service delivery. So really empower the users in the business community. We'll go a little bit into our existing state when we began the effort. And this is just going to show a lot of the challenges I think will be very familiar to folks in the audience here. We have advanced users. If you're not familiar with the actuarial discipline in the insurance industry, they're the data scientists of the insurance industry, have been doing this for a very long time. Their business is doing calculations involving risk, and that's the basis of course of insurance. So they are well accustomed to dealing with a large volume of data. We also have other departments that have similar but slightly different needs. Well, okay, obviously there's endpoints involved just to make anybody be able to work. So we have these workspaces, desktops, laptops. We have data stores that people can use, but realistically, we get physical limitations with on-premise infrastructure and legacy technologies, hit those limits very quickly. There's other physical boundaries involved associated with our mainframe systems. A lot of banks and insurance still have mainframes, and they serve a critical role. obviously, we're looking for opportunities there, but that's a natural piece of, that's a natural limitation. And then when we do have databases for enterprise use, again, physical limitations, very easy to hit, where provisioning something more means that we provide an additional database, but we start hitting the challenges of, well, how do we make sure that can be integrated with other data? I have no doubt that working with infrastructure, we could have solved these things, but what we knew for sure is the price point to get orders of magnitude of improvement were going to be orders of magnitudes of dollars, and that's not in the cards. So our approach on this is make sure that we have a clear criteria, keep our focus on transformational level of change to what we're doing, make sure that we're leveraging the modern technologies and keeping the focus on those end users so they can actually see the benefit, get what they need without IT being in every interaction, keep the security of the platform uncompromised, and also, again, keep the price point where it can be actually a viable solution. So what I'm going to do is pass it over to Dilip Kumar. He's the Senior Manager of Data Engineering at Globe Life, and he also is responsible for maintaining our cloud data platform and incorporating all the project innovations that we have. Dilip?
Thank you. Thanks, Arthur, and thank you everyone for joining here today. I'm going to walk you through the technical solution we implemented at Globe Life to meet the challenges what Arthur just said. Our goal was to build a secure, self-service data and analytics environment. And in order to meet that, we needed basically these components in AWS. User endpoint, so that our end user can securely access cloud data assets and run analytics locally in cloud. We need to build the data lake because data has been scattered or some even unknown. So we need to bring the data from these various sources to a central location, as well as we need to catalog them for the ease of self-service. Also, we have various user-managed applications where database need was relational. So we are looking for some sort of RDBMS in cloud for those needs. Also, at Globe Life, we have many SQL Server databases, which is more suited for analytical, but they were in SQL Server. So we are looking for some service in AWS, which can have some features like MPP, massive parallel processing, as well as columnar storage, so that our end user can run their complex query on their huge data set efficiently. Also, to process, parse, and transform all this data and run the models, we needed compute. We were looking mainly for serverless, but there are a few scenarios, like running some of the models where we needed Windows instances. And overall, we needed some tool to orchestrate and manage all these data pipelines and model execution process. So before doing a little deep dive on the technical architecture in AWS, let me quickly glance through our on-premises architecture, what Arthur was saying. So as with most of the financial services company, mainframe legacy system is our system of records for most of the data sources. Mainframes are reliable and stable, there's no doubt, but it was hard to meet the dynamic and enhanced need of our advanced analytics group. Also, as I said, the data from them were not centralized so that end user can access easily. We have various enterprise SQL Server databases for various enterprise applications, as well as for in-house data warehouse. Those were to satisfy some sort of our on-premise data warehouse needs. Also, we have ETL servers for extract, transform, and load the data from various sources, like mainframe or other sources, to our enterprise data warehouse. BI server, as usual, for reporting and dashboarding needs. And we have few machine learning server also on premises to satisfy and run data science models on them. Then we have a lot of various advanced analytics groups like actuaries, data scientists, and many more. So they had a need to interact with enterprise data assets and run their analytics. So for them, at on-premises, we came up with architecture before going to cloud of calling as analytics workspaces area. So it was basically a network isolated area where they were giving an access to the enterprise data assets, but also they have some control. The user has control in that. The user has individual VMs or machines to run their analytics. They have dedicated SQL server and file servers, network file shares. Actuaries used to run the model on the individual machines, and output from them were loaded to SQL servers. These all were good to provide some sort of self-service capability within our security guardrails. But challenges just started, especially in the past few years when the need of compute and storage grew exponentially to satisfy, to meet or address some of these our new requirements. So the data volume increased almost double to triple every other year. And the individual SQL server were already started running the limits. Now we need to add a new SQL server if they have more data. That is to take their own time. Also, the user individual machines and the VMs were not able to run multiple models simultaneously, which were needed by the new insurance requirements. So all these challenges, basically, it created, people started losing productivity because now they have to wait longer to run their models, as well as to execute their models. So all these challenges made us to think of a solution which can satisfy these growing demands of our end users. So I'm going to walk you through the high-level AWS architecture we built for our analytics, and then deep dive on some of the components. So first and foremost was needed to build a strong foundation in AWS for our self-service. We needed to make sure we have proper AWS account strategy, network segregations like VPCs, subnets, as well as connectivity with on-premises, like having a direct connect with proper bandwidth. After doing this initial foundation, then the next task was to ingest raw data into cloud. We have mainframe, which is system of records for many. Then XMLs. In insurance company, we have for electronics application submissions, and various other sources coming from various other systems. Then we have a lot of data housed in SQL Server databases. So we need to ingest all of them to the cloud. For the file system, we found our enterprise file ETL tool had a nice capability to ingest them into cloud. Whereas for SQL Server, we found AWS DMS, Data Migration Services, is very powerful. And DMS actually supports one-time full load as well as ongoing replication to cloud. For data lake, we followed our Go serverless first principle. We built a serverless processing framework which consisted of AWS S3 for storage, AWS Lambda, and AWS Glue for compute, and step functions for workflow, and AWS Glue Catalog for cataloging or metadata management. Amazon S3 has been the obvious choice because S3 provides high reliability, high availability, high security, as well as you can virtually scale to an unlimited at very low cost. So in S3, we followed some standard reference architecture, and we created 4 layers. Landing layer, where data is ingested from the source. Then raw layer, where data is native as source, but in readable format by some of the query engines. Then we have refined layer, where data is defined as well as curated. And the last one is the published layer, where the data is modeled for general business intelligence and data analysis needs. For compute, we have used AWS Lambda a lot. And here, I would say we have done some amazing work. Before building this data pipeline, when we had to ingest a data or extract a mainframe data set from mainframe and load to a SQL server, it used to take 3 to 6 hours for one of the master data sets. But when we build this data pipeline, the overall time reduced to just 15 to 30 minutes. So that was amazing. We also used AWS Glue for offloading some of the heavy compute-related data load processing, like if you have to compare the 2 deltas between 2 mainframe cycles, AWS Glue job with PySpark is great there. And then overall, we definitely need to build data catalog because that is very important. If you don't catalog them, the data lake will become data swamp very easily. So AWS provides AWS Glue Data Catalog to easily manage and store metadata. It is similar to Apache Hive Store, where you can store, annotate, and share the data lake metadata. Also, not only this, AWS Glue Catalog also helps to provide audit and governance on your data lake. Then AWS provided this serverless function called step functions. That was amazing to do this all orchestration around the various data pipelines. For database and analytics, we found Amazon Aurora was good for the data need, which was more transactional or relational. Amazon Redshift, we did good POC there, and that was good for analytical ones. And then Amazon Athena is great for running the query against the S3 without storing data into some databases. Then for user endpoints, we found Amazon Workspaces is great, where it helps user to securely access cloud data. And also, it provides some good capabilities. I'm going to double click on that in my next slide. Also, we found the BI tool, the enterprise BI tool, what we have has a nice capability to interact with these various AWS data services. And we have followed industry best practices for security, like principle of least privileges, centralized identity management, as well as data encryption in REST and in transit. We have used AWS KMS for data encryption across various data services. AWS IAM is great to provide identity and access management across all these services, and Amazon GuardDuty helps us to continuously monitor our AWS accounts and workloads for any malicious activity. So let me double click on the Amazon Workspaces. So why Workspaces is so important in the analytics world? Number one, because you know that these users are dealing with a lot of sensitive data. So definitely we want them to access this data set in a secure way. So Amazon Workspaces provide us a way to isolate this user from other like restricted network access, no emails, as well as user stays local to the data. So there is no transfer of data over the network. Also, it scales up and down very efficiently. If you have a workspace bundle, like a standard or power, and user need more compute, you can easily bump up to like a performance or performance pro. Similarly, if they're done with that, you can scale down. Also, if you have to enable a different department, let's say today we enabled actuarials, tomorrow we want to enable another department for these use cases. Workspaces is like you can launch within minutes for the various number of users. And number three, which is very important, it provides capability or compatibility with various analytics tools. So in our organization, we are able to use Workspaces with various commercial, open, and as well as open source utilities. For example, like we are able to use Anaconda with Python and R. And the people from various self-service personas, what Srikanth was mentioning, are able to run their models and run their data engineering needs in the Workspaces. Also, we have used like Cloudberry, which helps the user to browse S3, similar to a network share. User can store their files in the S3 and browse using such tools. The another tool I would like to mention, SQL Workbench, that provides a unified utility to access Aurora, Redshift, or Athena. So all these things makes the Workspaces as a go-to area where analytics users goes there and then access all their needs and run analytics locally. So you can see in this our architecture diagram, the first thing, user connects to the Workspaces using two-factor authentication as required by our security policies. Once they are in the Workspaces, they have access to the enterprise data assets like data lake or enterprise data warehouse based on their requirements. And then we also created an analytics Workspaces area, which is basically various services based on the department needs, like a dedicated Amazon Athena workgroup, Amazon Aurora cluster if they have some need for RDBMS, and then Redshift for a lot of their analytics needs. We have also Windows FSx Share for their network share needs. Moreover, we have also used AWS SFTP so that a user can transfer files to and fro from this workspaces to a local computer for their any ad hoc needs. And overall, all this, we have followed the best practices for security. So that helps users to stay within our security guardrails. Now, after building this data platform and creating an analytics workspace area, the other challenge we had was, for one of the department, we have to migrate the data to cloud. We have around hundreds of databases in SQL Server and more than 100 terabytes of data which need to be migrated. And not only the data, they have also process associated with that, especially in like SQL Server procedures, functions, and they need to move eventually with the data. So we did some initial POC for deciding on like what should be the target, whether it should go to Aurora, or it should go to Redshift, or it should stay in S3. So we worked with our AWS partners and did some POC and found that Redshift and Redshift Spectrum was able to satisfy or deliver the performance within all the parameters what Arthur was mentioning. In one of the use cases, we were able to run a query on our more than 10 billion records and within 23 seconds for several months of data from the X-Series team. Also, when we put like the historical data in S3 and the just latest data in the Redshift, we are able to use Redshift Spectrum and the same query, just joining those two data sets, we are able to run within minutes. So that was amazing, which we knew that we were not able to run those in the SQL servers. We also did another POC before deciding on the Redshift, where there was a process running with a set of procedures on SQL Server. We just did a lift and shift of that procedure on the Redshift, and that procedure, which usually takes a couple of hours to run on-premise, it was executed within 7 minutes. So after deciding to go with Redshift and Spectrum, now the other challenge was data migration. We want this data migration to happen, but also we don't want IT every time in between. So we needed to choose some tools, like which tool will be helping for migrating this huge amount of data. We have various choices from AWS. AWS DMS is a great choice for migrating data over your data connect network. Then SCT agent, that is also good for if your target is Redshift or S3. Then also Snowball Edge device also provides good capability if we have to ship huge amount of data to cloud. But our need was self-service. So looking on various requirements and these options, we found AWS DMS will be best suited to do our job. But we don't want end user to give AWS console access so that they can go and manually create. So we wanted to build some process where user doesn't need to interact with the console, but still they can trigger the data migration and get the notifications. So for that, what we did, we created a DMS template generation program. We use Python a lot, so we created that program using Python. And what it does, user provides inputs in a template about the SQL Server, source SQL Server database, their tables, which they want to include or exclude, the server name, as well as size, like partitioning size, if they want to group in any fashion. Based on these inputs, the script which we have created for DMS template, it scans the source system data and analyze it and group them into various group of tasks. Because we know like if we put everything in one DMS task, it won't go faster. So we need to group them intelligently. So this Python program analyzes that and then creates the input for CDK. CDK we use a lot in our organization because everything we make sure it is infrastructure as code. And so this Python program generates input for CDK, and CDK takes that input and creates CloudFormation template for deployment to cloud. Once the whole process is executed, the DMS tasks are deployed based on the user decided targets like S3 or Redshift, and the data is migrated to cloud. Also, we have used AWS SCT a lot and enabled end user to use SCT so that they can use to migrate the store procedure and function while the data is getting migrated. So with this solution, we enabled our actuarial team to migrate their data with reduced IT dependency. So after data migration, there was another requirement. We have to run the models. At Globe Life, we have valuation and projection models which needed to run. And we have various line of business, and each line of business has several models. So as I said earlier, the actuaries team used to run the models on the individual machines, but the requirement was now they have to run multiple models at same time, which they can't run on the individual machines. So we needed a solution where a team can run multiple models simultaneously without waiting for another to finish. So also, this solution needed to be cost effective because there was a need that some of the models now require high compute capacity, which is hard to meet in the on-premises. So we came up with this solution. So we have a model management application, which is developed by our Globe Life team. What it does, it provides an interface to our actuaries to execute the model in AWS. It also manages the audit information and model metadata into SQL databases. The user using this interface provides the inputs, like which line of business they want to run, which model they want to run, and what are the steps they want to run, as well as they can provide the compute requirement, like which compute requirement they want to run. Based on that, this model management application bundles the input config file and sends it to Amazon S3 through S3 file gateway. As soon as the config file is there in S3, we have an automation Lambda, which is getting triggered. This is basically core of our engine, that automation Lambda. What it does, it parses the input config file and then does a couple of steps. It creates the system manager automation document for the various steps need to run. It also launches EC2 machine based on the compute requirement given by the users. And then it tells system manager to go and run this automation document on the target instance. All these executions are logged in CloudWatch, and then we have Amazon Event Bridge to filter the various status of the job IDs and send it back through a Lambda to DynamoDB. And then on the top of DynamoDB, we have an API. It sends the status back to the model management application for user to know which steps the model is running and what is the current status. Also, the output of this model is saved into S3, but moreover, it is also loaded to Redshift at the same time. And that helps our end user to query this model output efficiently without loading back to the SQL Server or bringing it to on-premise. From there, once the data is loaded into Redshift, the team is able to use BI tools. They are able to use SQL Workbench also. And also, one of the examples I found, they are even able to connect Excel to the Redshift and get the data and get their business insights. So this is how we enable the actuaries to run multiple models simultaneously without waiting for their one model to finish or run various scenario testing without getting into any conflicts. Also, the Redshift performs well here to query the data, even there is billions of records there. I'm going to walk you through some sample scripts which we did as the part of this model execution process. So as I said, the automation Lambda is the core of this whole process. It takes the input. We have a PS automation class created, which basically the core of this process. And then what it does, it calls the initiate Lambda, which does some basic sanity check of the model. It also parses the config file and makes sure everything is correct and there's no errors. And then it passes to the setup automation process. The setup automation process does two steps. It creates SSM automation document. It also launches the EC2 machine. And then in the last step, it asks system manager to run the system automation document on the target instance. So here, a couple of things. We are able to use EC2 machine of the choice to run the models. Also, we don't need to wait for one model to finish because you can scale easily in the cloud. And now user doesn't have to wait for their models to finish before starting the other model. So with this, we enabled our actuarial team to run multiple models. With this, I'm going to hand over to Arthur to conclude this session with the benefits achieved, lessons learned, and some future plan on delivering self-service analytics to our end users. Thank you.
Thanks, Dilip. Every time we tell the story, I brim with pride in what the team's done at Globe Life. It's really extraordinary, and as we walk through it and see all the details, there's so much that had to happen to make this occur. But then the end experience is that there's a ton of freedom that the end users wind up getting with all the parts put together. So let's talk a little bit about the benefits. We've talked about some of the statistics already, and go back to one of the litmus tests that we want to have is, do we achieve orders of magnitude? Are we taking approaches that actually take us to a completely new level? And Dilip mentioned the use case of running the query against history using Redshift that can happen in minutes. But the comparison there is that it doesn't even work in our legacy environment. You literally can't do that. So that's an infinite increase in performance. You can do something that you couldn't before. But I think that there's a stepping down a little bit from that. We have some queries that we run against the mainframe data. The jobs in the mainframe that we had took several hours to run. That logic got recreated inside of Athena to a binary match of the results, and that runs in seconds. So going back to the technical definition of an order of magnitude, that's factors of 10, multiple factors of 10, and that certainly hits it because we're at 3.5 or so orders of magnitude. And I just want to take a second and say, well, what does that actually mean from a benefits, if we talk about innovation in particular? So I want to connect this to innovation and self-service. So obviously when you run something faster, you get the answer sooner. So the time to business value is shorter. That's value, right? Getting things earlier. There's also the characteristic that, especially when you can run a lot faster, you actually you have time to answer more questions, right? People can actually take that time and turn to the next question and actually answer more business questions, get more insights. But I really want to highlight here that when you say, well, what about innovation? If you can make something thousands of times faster, then it really changes the game, because now you're talking about query times in seconds for a data scientist, for an analyst, and they're able to then maintain continuous thought on the topic where, again, go back to the legacy environment, run a job on the mainframe and wait till tomorrow, and I had to interact with IT and submit jobs. Now, obviously, that's an extreme example, but again, that's exactly where we want it to be, is to have something that's transformational. And that's very exciting. People can maintain continuous thought on an analytical topic and iterate. And that's really the speed for innovation that we can achieve we've actually seen that in many of the areas of the processes. It goes without saying, though, that, of course, this couldn't be achieved with our legacy technology approach, because we would have had to scale up hardware to the peak need, right? So the scalability, that elasticity, the models that we want to be able to run, again, the models can all run at the same time. And we have yet to find the limit of how much can run simultaneously. So it gives us a lot of runway for future optimization that we haven't totally consumed. Also, performance. The 91% improvement going to Redshift. I'll just highlight there that after we worked out the bugs in the process, the actuarial team was able to take their data and their stored procedures, and without any help, do the migration and get a 91% improvement in performance without optimizing, right? So again, room for growth even beyond that, and certainly enabling self-service. The other thing here is that as a platform, of course, something that we like about AWS is that these are integrated services and capabilities. I'll give you two quick examples here. Dilip was talking about the encryption. Before, when we were on premise, we used to have a debate about which data should be encrypted. That's over. Everything gets encrypted. Everything. And it's because it's a platform, right? And that's, again, where can we be transformational in our thinking and taking advantage of what we can do. The other thing is specifically on the slide here, the federation. So when we talk about federation, we have different tools, different ways of storing, different ways of performing the analytical queries that can be optimized and tailored to the needs. So this is something that I'll admit that I think we kind of went through a journey of decisioning, is that originally it's like, hey, we're going to migrate to the cloud and it's all going to be one thing. But no, actually, it doesn't need to be one thing as long as everything talks to each other, right? And that's what we've seen, is we can take the data that's in S3, which is part of the data lake, we can have queries that leverage it for Athena. We've worked out all of the combinations here, tried everything out, and it's working very well. So the dynamics that I'm sure you deal with a lot of your partners in the business would be, people making copies of data because this doesn't talk to this. Well, that's not something that we have to deal with now. And again, that's all time that we're actually not spending on this, and then therefore working on other business use cases that add value to the company directly. I think on the benefits achieved, we certainly also have met the needs for the regulatory requirements and then some, because that performance level of simultaneously running these models is so high. That doesn't mean, of course, that we're done or that there were no challenges. I think as you see what Dilip shared, there's clearly a lot of infrastructure and foundation that has to be established in order to get the outcomes. We said we're going to encrypt everything across the board. Well, we actually had to say, well, wait, we're going to use KMS. We actually have to come up with a strategy of how do we work with that. We worked with our partners in IT security and information security to come up with the way that's going to meet our requirements and our policy. So really that planning of saying, what's the starting point? What do we have? Where do we not have the foundation that we need? I think that the procedure, the process that we've embraced is definitely keep a backlog of everything that we know is part of our future, make sure it's synthesized into a proper roadmap though, and then and be really crisp on what means success at each stage in our process. So we did Redshift, for example, the POC. We talked with AWS, we came up with a strategy. They truly worked with us as partners. And that was actually our first interactions with Srikanth. We were able to, on our side, be very clear that literally here's every box that needs to be checked to make this something that's viable. And we didn't stop until we finished going through those. But we had to queue that up well in advance of expecting to use it, because not because of any platform limitations, but because there's an enterprise environment that we all operate in, I think most of our companies, that we have to work through all the details. So planning and the clarity on vision about what actually equates to success. The human element also, building trust with the business, I can't express really enough about that. We had to make sure, if we're not going to be order takers in IT, we have to earn that. We have to earn the partnership. And it becomes something as basic as just believing that your client has a valid concern, your customer has a valid concern. The self-service idea can be very threatening in the IT organizations. There's a place that people do things that we don't get involved in. And it's working with data. That can be a little frightening. But we had to truly embrace that, right? That they do it now, and we're going to make sure, though, that they can do it and they can take advantage of these tools and be able to be fully compliant with all of our security controls. And that becomes something they don't even have to think about. They just have to be in that environment. But we didn't get to that point without actually embracing that vision was something that could actually happen, and that we would focus our energies on solving the needs of the actuarial clients. And that's what makes the trust actually work, I think. The other thing is just also being very cognizant of we talk about having a range of solutions depending on what the different outcomes are. So part of that then becomes, well, what is the actual population of actuaries? What are they ready to use right now? Well, it turns out that they are experts at SQL, so standard ANSI SQL code, more than most people in IT, frankly. They've used this so much. Well, that meant that when we were looking at the solutions and saying, well, what's the first stage? It's part of why Redshift actually worked well. SCT tool, let us convert code, lets them convert code. The syntax is very similar to what they're familiar with. And that becomes part of, the enablement is that you have to have the adoption for this to be considered a success of any kind. That would not have happened if we hadn't been sensitive to the fact that that's a transitional state. We say, hey, you guys really ought to learn some Python. And there's a lot of them that have embraced it, but it's also something that is going to take a lot of time to develop as a capability inside the business teams. And then the last thing, I already addressed this, the self-service is changing. I don't see that 5 years ago that there was even a way that what we did, it wouldn't have been possible. Too many things have had to come into place to make this a possibility in the way that we did this. The introduction of new services throughout our journey really make or break for whether we can even give self-service in the way that we're doing it now. And I don't see that that's stopping. So you're constantly looking at what is it that is going to be changing with self-service? How can we continue this journey with our business partners? And that's really just what's queued up next. So going forward, with what we've built already, we have something that can be applied almost completely to some other business units. Now, of course, there's always going to be the Venn diagram here. Things that are unique to actuaries, the model execution that Dilip mentioned and walked through, requires a Windows engine, and it's very particular to the actuarial space, right? So that's something that probably doesn't get leveraged directly as we talk about another team. And then, of course, vice versa, on the things that in one of the groups that we're trying to work with now, and getting started with is the marketing team, marketing technology team. They have some needs that are very different than the actuarial team because they have to manage campaigns and be able to send out communications, which is not really provisioned for in our current design. So we need to work closely again and keeping the open mind about let's make this success for our partners. Let's make it success for our enterprise, for Globe Life. So we'll continue that journey. We want to onboard other people into the environment. And again, it meets a lot of needs now, but if we pretend that there's no customization or enhancement for different audiences, then we're not being realistic. The other things I'll throw out here is that this came in fairly late for us, and it's a fairly recent offering, the managed workflow for Apache Airflow. That's a great example for us. Our first order of choice is always serverless if we can do it. Second order is, hey, if we can't get serverless, let's have a fully managed service that all the servers aren't our problem. And for us in our scale, that's really critical. So we've now prototyped and actually deployed, thanks to the team, the awesome team I work with. We've been able to deploy that to a first audience, which is the actuaries, but we really want to use it in IT, and we haven't yet. So we have to work through that and look at where some of the opportunities are. Also mentioned lake formation. We actually never, the timing was amazing in terms of when that was first released. And again, it's something that we went into, we reviewed it. This is its capability when it was first released, and the timing was just not right because we had already committed the full path on everything that we were doing for that first MVP of the data lake. Well, obviously this is the opportunity now, and the service itself has evolved. So when we look at how do we manage the access control at a fine-grained level for large sets of audiences as we add different groups, but also we have hundreds of data sources in the enterprise data lake now. Obviously, that's a more and more valuable prospect. I also just throw it out here that when we look at models, and there's in the actuarial space some very particular types of models that are only built by actuaries, and the tools are very specific. But even the actuaries use what you might think of as the general statistical learning type models, and there's the potential to use, say, neural networks. So machine learning capabilities are really important. But again, how do we do it efficiently? How can we do it such that IT doesn't need to be involved? And this becomes another way, right? So service like SageMaker, we see a big opportunity to have something we can deploy to the various audiences inside of the company and be able to, again, let them serve their own needs. Because again, if they come to IT in between each model they want to do, it's not going to work. It's not going to work. There's just not enough people in IT. There never will be. So we want to make sure, again, though, that when we use it, that it meets all of those enterprise controls that got built into the platform. And that's obviously the opportunity for us on SageMaker. So I'd like to have Srikanth come up, and Dilip, if you can stand up near the stage, just to express my appreciation for the time that you've invested with us. Again, I am so privileged to tell the story of what we've achieved and where we're going. So thank you to all of you. Thank you to Srikanth and Dilip. Thank you for sharing today.
Yep, thank you, everyone. Appreciate
Thank
it.
you.
We'll take a couple of questions in that corner.
Yeah.
Thanks.